This is the fourth session. The first session was an overview where we introduced you to the concept of a fabric and how Brocade's VCS comes together. In the second session, we talked about converged storage networking and how combining storage on a network, how it looks, and discussed some of the topics around that. In the third session, we talked about multi-chassis versus trill and multipathing. We sort of did a bit of a deep dive and some whiteboarding around there. So this is the fourth session, hard cores and soft edges, which is Ivan Pepelnjak again, returning. Yep. And Chip, returning for another event. Derick Winkworth at Cloud Toad. He's quite famous for his expostulations of vehement denial of all things physical network and the empowerment of virtual. Is that true?
It is very true.
Yeah, and so I'm looking forward to some challenging questions from you. Tom at Networking Nerd and networkingnerd.com.
Net.
Networkingnerd.net. .net, known for expounding extensively with snark. Sometimes known as snark, just for short. And with his power mullet, Mr. Tony Bourke returns. And of course he is at datacenteroverlords.com. Not enough power in that name to, so overlords or whatever. And he is also on the Twitter as @tbourke. I'm Greg Ferro. You can find me on my blog at etherealmind.com and on the Twitter as @etherealmind and all various places around the world. Why don't we kick it to Ivan and you can talk to us about your presentation?
Thank you. So I just spent 3 minutes explaining the problem to everyone who hasn't seen Tony's slide at last Networking Field Day event. So as we all know, due to lack of creativity and imagination, the only solution we have in most cases for tenant isolation in virtual networks are VLANs. And the problem is that we have a layer 2 switch in the hypervisor that is pretty bad at telling everyone else what it needs. And actually, typical VLAN provisioning this year looks like this. If anyone remembers the poor ladies that were moving patch cables in the old voice switches, this is how we do VLANing in 2012. The server can't tell the network what it needs, and the network can't accept that information, so we have to pass the trouble tickets, as you said. Or the other alternative that most people that just give up adopt is, I'll give you a VLAN range, you do with it whatever you wish. And then we, of course, go into the problems of broadcasts and network meltdowns, and I've seen a few networks melt down because of large spanning tree domains. There are a number of companies that are trying to solve this, and I'll just present 2 and then ask Chip to tell us how Brocade is different and what they do. Cisco UCS is one typical example, and HP is doing something similar with EVB and VEPA. The idea is, let's bypass the hypervisor, let's just pull the traffic out to the physical switch and turn it around there. The problem is that the hypervisor sort of resists that. So Cisco had to insert a switching module in the hypervisor that does this bypass. Arista, for example, represents a different class of solutions where they actually use something like CDP to send to the servers, and then they communicate with vCenter and try to figure out where the servers are actually connected. Because VMware can't tell you where the servers are connected. And they wouldn't even send CDP updates by default. You have to configure that. So we figure out where the servers are, and then we are listening to vCenter very carefully. And then as a VM moves from one physical host to another, the vCenter would tell us that, and we would have to go into the port group and figure out what the VLAN is. And then we would configure that VLAN on another switch. But of course, that just solves the immediate server-to-switch provisioning problem. It doesn't add any value. And it doesn't reduce your broadcast domain, because you still need all the VLANs on all the switches. You just don't extend them to the servers. And now let's see what Brocade has to say, because I know that you have some fantastic features, and I know that you'll explain them very eloquently.
I would say this is not the best picture of me. It turns out that my Transformer pajamas brought back a lot of nostalgia, but I probably shouldn't talk about that right now. We've taken sort of a fundamentally different approach to this whole thing. The approach that we've taken is that instead of making the network bigger, we're trying to make the network invisible, because what we've found out is that because of things that the network won't do, we've had to divide the responsibility of managing the network up into two different pieces. Now, I will put a caveat based on the slides that you just presented here, which says that in order for us to be able to do anything, we have to be able to see the traffic. We have to be able to see it. Now, that introduces some strange situations today, because as for reasons you've just very eloquently yourself described, it turns out that we need, of necessity, a software switch that lives on a hypervisor. And just to recap that very, very briefly, the reason we have to have that is because networking is kind of broken. In that because I'm not allowed to have hairpinning, if I have a particular virtual machine and I wanted to talk to another virtual machine on the same node, I have no choice. I have to do it internally, because if I send that frame out to the rest of the network, it'll be rejected. It will not come back in on the same frame. And there are some people that are looking at different mechanisms for solving that. For example, do we have an adapter that lives inside of the hypervisor, or I should say inside the server space, that's responsible for doing the switching, or do we move everything out to the edge? And once again, before I start getting into our AMP solution, I do want to say that from a networking viewpoint right now, we don't care. We actually support both of those. We do have networking adapters that will support switching inside the server. We do have server ports that will allow you to do that type of hairpinning that I just described. And as we sit right now, at least at the time of this taping, we're sort of at the mercy of the hypervisor vendors to sort of get out of the way and allow us to do things. For example, we have HBAs and we have cards that are embedded now, which can expose a huge number of virtual NICs and virtual HBAs going all the way up to the virtual machine, so that using technologies like SRIOV, you're going to be allowed to have a virtual machine that completely bypasses the hypervisor and then talks to the network. Now, I think the thing that's interesting, that I think is going to be interesting to watch for a little while, and I don't know how this is going to turn out, is that as we start to have standards-based solutions that are going to allow the hypervisor to get out of the way, will they in fact? I think that we've seen some things that haven't worked very well. For example, the idea of adding another management interface to the embedded switch so it looks like part of the network didn't work, because what we've seen is that the hypervisor vendors now have lost control of this soft switch, and we've increased the number of switches that need to be managed in the enterprise. So we haven't made the situation simpler. In order to be able to manage it, we've actually made it more complex. So what I'm going to talk about here from a fabric viewpoint is I'm going to start from the assumption that we can see the virtual machine traffic. I'm going to assume that either the two virtual machines are not living on the same node, because otherwise it's hidden from me, or I'm going to assume that we're using a pass-through technology or something like SRIOV, standard-based technology, to allow me to see that traffic, and I'm going to see it from there. I think one of the biggest differences between the way we're approaching this and the way it's done in the past was touched briefly in a previous session, where we talked about the difference between procedural-based management and policy-based management. Policy-based management basically says, if and when you see this, this is what you do. Procedure-based management says, go out and do this now. So for example, and I know people who are who have a history with Brocade are saying, I wish you'd just quit saying this. But I need to bring it up because I need to establish the fact that what I'm saying here has precedence behind it. If you look at the way management takes place on a storage area network based on fiber channel.
Oh, we're back to storage.
We're back to storage again. We're back to storage.
Yeah.
The thing that we did is we established policies. Here's what the policy said. Here's a worldwide name. Here's a worldwide name. This one representing a storage array. This one representing a host. Wherever you see those two appear, let them talk to each other. If they're not there, they don't need to talk to each other. And no matter which port they come in on, they're allowed to talk to each other. So now that element of intelligence that's in the network says the network can reconfigure itself on the fly. So for example, if something happens and I have to yank a cable out and plug it into another port, through a policy, the network has a just-in-time solution to reconfigure itself. Or if I know that I'm going to be getting a new number of storage arrays in, I can pre-provision those, and all I need to do is plug them in. This makes some security people feel good. This makes some security people feel bad. For example, if you think about a storage area network, because I have the ability to do this zoning, I want you to think of the difference between, and this is how it gets back, I'm going around the mountain, you gotta trust me, the boat's turning. The boat is turning. What happens is that if you look at the way storage people are set up, On the SAN side, they'll say, all my ports can be active. If I have something that happens, I can plug it in, I can authenticate who that agent is. After I've identified who's coming in an absolute secure fashion, then using policies, I'll set things up. No management intervention necessary. So that means all the ports on my fabric switch can be turned on. Now think about what happens on the Ethernet switch side. If I talk to anyone working in the security space and say, I want you to have all your ports turned on, what are they going to say?
No.
Yeah. Have you lost your mind? I mean, they're going to, no, we're not doing that. And then the question is, why not? And the answer is, because we depend on procedural-based management. If somebody has done the wrong thing on that port, for example, pre-provisioning a large group of VLANs, then suddenly a ne'er-do-well or someone who's not doing exactly what they should be is able to inject an element into the network that shouldn't be there. The idea of saying validate who somebody is and then give them the right permissions based on policy doesn't exist. It's all procedural, it's all management. And that's where this whole idea of having to open a help ticket to the networking group every time I want to change becomes necessary. We would argue to say it's a lot more secure to actually say, suppose I do plug something in. Who are you? This is who I am. Can you prove it? Yeah, I can prove it. Here are my credentials. You know what? Since I now know exactly who you are, I'm going to look to see what those credentials get you. I validated who you are. I'm going to go out and configure that port. That technology has been brought over to the virtual environment now through this thing called port profiles and AMP, which stands for the automated migration of port profiles. It's actually just as good for the initial provisioning, but AMP's kind of a cool name. So it's automatic, So what happens here is that, suppose I have a hypervisor server that's sitting out there. By the way, for the purposes of this discussion, I won't be telling you what the brand of hypervisor is. And it's not because the hypervisor brand, I don't want to give them a plug, because I would, but the truth is that what I'm talking about here doesn't depend on any interaction from the hypervisor at all. That is to say that you can bring up, Zen or Microsoft or VMware or anyone you want to, and you can get exactly this behavior. What happens is that a network administrator will go in and will define a set of port policies. These policies basically say, here's the VLAN, here's the quality of service, here's going to be the access control list, here's all the other parameters that go around a particular port, but I don't know which port that's going to be yet. The next step is something called activation. And in activation, this is where you go through and say, if you see this MAC address, here is the profile you're going to apply to that port as it relates to that MAC address. And so now, for example, I have a hypervisor that's sitting out there. They create a new virtual machine. They assign a MAC address to that virtual machine. The first time they fire up that virtual machine, because that MAC address has been associated with that profile, they connect. The system automatically goes out, automatically configures the port, automatically puts it on the right VLAN with the right quality of service, with the right access control list. It's done, and it's done in a way which has already mustered the security people. Because you've said, this MAC address, this is exactly what it's going to look like. Security people say, yep, we're good with that. The strict enforcement of that policy guarantees that that virtual machine can now be added to the network no matter where that virtual machine lives.
Now, are you talking about physical ports or logical ports when you talk about ports?
In this case, let's start with a physical port. We can set this up for, let's say, a hypervisor server. So that we can say when that hypervisor server first comes online with this MAC address, give it the configuration that a hypervisor server should have. So for example, if there's clustering or something going on, it can communicate traffic going back and forth amongst the others. When the first virtual machine fires up, at that point, we're going to see that new MAC address. We apply the port profile to all traffic with that MAC address, so we can actually have different profiles for each of the different MAC addresses.
So you're actually creating like virtual ports tied to source MAC addresses, and then you apply whatever policy you wish to that virtual port based on the source MAC address of the packet coming in.
That's a great way to look at it.
Okay.
That's a great way to look
sense.
at it. And so now what I've done...
So that means you've got the profiles. So now we've got a virtual profile in one switch. But in reality, that MAC address could go from this switch to this switch to this switch to this switch. So
That's
that
right.
means the profile has to be inherited or hierarchical or transmissible.
It's exactly right. And that's why in the previous diagrams, when we were whiteboarding, when we drew the fabric, we always drew this boundary around it. because that fabric represented not only the boundary of doing this trill switching, but it also represents a management domain.
Right.
And so, for example, on that slide where I have that little database, once I add that configuration to the network, that configuration, so depending on when you're seeing this,
Yeah.
gentle viewer,
Yeah.
there are a couple different things that could happen depending on the mechanisms that you're using. In some case, it's done by having a higher level tool distribute that profile to all the switches individually.
Yep.
In other cases, it's done by giving it to one switch and having that switch propagate the information throughout the fabric.
Okay, so that's a key point there. One is Brocade has the virtual chassis concept. And you can actually define all the switches to be a virtual chassis.
That's right.
Which means you can take 10 physical switches and say you are just one configuration element.
That's right.
And the you see all the ports as, switch 1/whatever, switch 5/7/. So that's one way of taking all the switches and binding them into a virtual chassis. And there's a bunch of rules around how virtual chassis come together. And there's certain products that can't participate in the virtual chassis. So you have an external server, which is presumably some sort of software package that distributes the configuration between all the switches.
It can be.
Yep.
We do make an external management package, but you can also do that by going into an element manager on one of those nodes and have a distributed configuration manager distribute that information also.
Okay. So port profiles, even though it's not just one switch, it's a coherent system. All of the Brocade switches cooperate to exchange configuration data. Configure the port profile in one, and the port profile is shared between all of the switches in the network. And then when a MAC address switches from this physical switch to this physical switch, it goes, hang on, I've got the port profile for that MAC address. I'll apply these policies, this VLAN, this access list, this filtering, this redirection, whatever it is, and then transmit it according to that and then forward it across the fabric.
That's exactly right. And one other subtlety of what you just said I want to highlight for just a second. That illustrates the difference between a fabric and just a network of switches that are put together with Trill. And that is that there's another protocol that's running, probably across a TCP/IP protocol, where I've got not only link state information going back and forth, but I have fabric consistency information that's moving back and forth to guarantee in, let's say, a two-stage commit, that everybody has exactly the same view of the database, that everybody's consistent out there, so that I know whenever there's a configuration change, everyone is on the same page before the commit goes in.
All right, so now I've got my Trill boundary. Virtual servers are here, 1, 2, on 2 physical switches. So if I move this hypervisor from here,
you move the VM.
When you move the VM, from this hypervisor to this hypervisor, the MAC address is going to move. So that means the hard edge will see the difference.
That's exactly right.
And now what we need to do is extend the management plane so that the virtual hypervisor and the network signaling is exchanging state or exchanging data so that you get visibility into what's in the server side.
That's right.
Right. Now,
to a point, I don't need all that because all I need is the MAC address, which is why I'm hypervisor independent.
Right.
I can do what I just described from a network management view. Now, as I'll talk about in just a second, there are some advantages if I have that hypervisor management and fabric integration.
Yes.
But I don't depend on that. So if you've got a Zen network or something else, you can still use this tool.
Before you go there,
yes, sir.
For those people who have been badly burned by VTP, what happens if you merge 2 fabrics and they have different port profiles?
Stock snotty answer. Sorry, I keep coming, every period I have to come up with my snotty answer.
We have to beat you up at it.
Yeah, I know you're going to have to take me out. I think I'm going to be a bloody pulp after this thing is over. The snotty answer is exactly the same way we've done it for the past 15 years in fiber channel fabrics, which is
what if you have an overlapping port profile definition?
So what's going to happen there is that at the time we go to merge this fabric, the management tools that we have start by saying, you have 2 conflicting sets of policies here. Do you want us to have communication between these 2 autonomous fabrics, which in a sense looks like 2 great big chassis talking to each other, which have different policies? Or do you want us to migrate these policies here, or do you want us to migrate these policies over here to converge the network? Now it turns out that you can actually make all those choices, and again, this is the advantage that people have who are considering fabrics in the Ethernet space today is that experience allows us to have developed the tools to understand these are the behaviors of fabrics that seem to be the most attractive. For example, deciding if and when to merge them and when to keep them separate. So that's where the snotty answer sort of. I get a
We've already done this.
I get a few points. That's exactly
So
right.
what you're saying is, done it for the last 15 years. Duh. What's new about that? Oh.
And I think that the easiest way to handle this in some conversations is that it's a little bit uncomfortable, but have the storage people, the fabric management people, come to lunch with the networking people. Because a lot of times the networking people will ask me a question, and I'll just say to the SAN person or the fabric person, what happens? They'll say, oh, here's all your conditions. The other thing that's good for the unity of the customers that I'm talking with is by doing this, now all of a sudden the networking people, instead of seeing the storage people as the unwashed them, right? I mean, all of a sudden now they start to build some things to say, there's some expertise in-house, which as we start to, watch how I do this. This is going to be really good. Which as we start to get into convergence, which was discussed in a previous session. How's that?
That was good.
Did I do that?
Nice
Did you like
segue.
that?
Nice segue, yep.
Thank you.
Bringing it home.
But as we get to the issue of convergence, there are already some people in-house, not a vendor, but some of your own people who may understand all the subtleties of dealing with that issue, or with those issues, as they relate to that.
Yeah. Closed?
Good.
Cool. That's pretty
cool.
interesting. That is pretty interesting. That's not something that networking has done. So networking, all of our policy has been manual.
That's right.
Right. So we would always, if we wanted to merge two switching fabrics together, in other words, switching fabric in simplified terms is this one's going to have a whole pile of VLAN IDs and IP addresses and routing. And if we wanted to merge two not connected Ethernet networks together, there's no.
Oops.
That's you would actually have to manually either remap them or reconfigure them at a fundamental level. So
That's
that
right.
idea of us merging fabrics together is it's not something we've ever considered.
It's from a different universe.
Yeah.
Yeah.
But a good universe, a benevolent universe.
The lossless universe.
So now for a second, I want to talk about a particular case, as we talked about earlier. We said that we can do this with any hypervisor, but obviously VMware is a very popular hypervisor that's out there today. And so one of the things we looked at is how do we make management simpler for a person working in a VMware environment just because of the installed base they already have, and we're also doing this for vCenter and other hypervisors as well. In that case, we now have tight integration with that vCenter solution, and here's what that looks like. When we go out and we set up these port profiles, if I don't know what the hypervisor is, then the network person is responsible for assigning the MAC addresses to the profile and so forth. But if I have the access to something like vCenter, which I have through SOAP, which I can do through secure HTTP, if I have access to those APIs, I can put a new tab on the hypervisor administrators that doesn't say what VLAN, all of it says is, here's a profile that's called SQL servers. If you create a new virtual machine and it belongs in that, just tell in this tab, this profile belongs to this MAC address, and they're done. No communication is necessary with the networking people. When that happens, vCenter telegraphs out through SOAP to our AMP technology, and we say, now associate this MAC, there's no network intervention that has to be done, which means now the just-in-time provisioning of virtual machines doesn't require you to talk to the networking people. The case point here that was very significant is we had a hurricane that was coming in through Florida where one of our customers was at. And what they needed to do is do long-distance vMotions from Florida to another data center that was located further inland. They didn't have enough time to call the networking people and say, okay, I'm moving over here. You have to set up this virtual machine to this virtual machine to this. And they were seriously looking at, I'm just going to have to stop the virtual machines and restart the applications there because I can't do it. But they had gone to Fabrics, or they'd gone to an AMP approach, and what the AMP approach allowed them to do was to basically transmit the profiles across two separate fabrics, so that now that other fabric was ready to receive those virtual machines that were going across. There's another example of this that we did at VMworld, where, for example, we migrated a virtual machine and its storage using storage vendors' technologies as well. We were able to actually, on the fly, move an operating virtual machine from San Jose into the showroom at Las Vegas using perfectly commodity networked, using whatever networking drop the hotel people would give us at the time. No network intervention at all. It was simply the hypervisor vendor saying, drag from here to here, and the network did the rest. It was actually quite remarkable, and it was interesting to see how it worked. And up until the day,
I believe you can make it work. We've been vMotioning virtual machines over 100 meg links. It's not exactly the best recommended practice.
That's right.
But yes, I believe you can make it work.
That's right. And for business critical applications.
Please, disclaimer, don't do this at home.
Oh, yeah. don't run with scissors. Don't do this at all.
Yeah,
That's right.
Just because you can doesn't mean
Yeah.
you should.
Exactly. So the secret of this is that we're able to get telemetry coming in from the hypervisor management tools, which is why it's so important for the hypervisor people to expose those sorts of things. And in doing so, instead of the networking people become bigger, if we do this right, the network just kind of goes away. It becomes a virtual extension of that soft switch. And I think that it's tools like this that are going to allow hypervisor people to say, you know what, it's okay if I don't have this soft switch anymore. It's okay if I take all the processing power and give it back to the applications rather than the network.
So in essence, from the point that Ivan made earlier, where other vendors are attempting to make the hypervisor go away, you guys are attempting to make the network go away.
That's right.
But,
A networking company.
But that's not what you just said. They'll be okay with the soft switch going away. Actually, I heard you say a couple different things.
Sure.
One approach is based on the MAC address inside a trill. It's more reactive. It sees a MAC address come in, it moves a profile over that port. That's one way. The second way is vCenter integration, where instead of listening for the MAC address, vCenter is going to tell you that a VM is moved, right?
Oh, I'm sorry. No, that's not what happens. It's we look for the MAC address anytime. The primary communication between vCenter and the fabric is I've allocated a new virtual machine, and here's what its MAC address will be, so that when you see it, you can provision the profile. The other thing.
Oh, I see. You're basically creating a way for the VM administrator to make the MAC address to profile mapping.
That's exactly right.
Yeah.
The other thing that we do is people worried a little bit about spoofing. What happens if I bring up a MAC address on the other side?
That was my question. Thank you.
Yeah, see, we're good at this.
The boat all goes the same way to come to port, right?
So what happens there is we've got tools built into vCenter so that when we see a MAC address for the first time, we can say to vCenter, do you know where this thing is coming from? And vCenter can come back and say, yeah, that's one of mine. That's good. I own that MAC address. I just fired up that MAC address. You may apply that profile to it safely. So that now we do have a sense of control that's going on here using vCenter's security feature.
That sounds like a hard topic to talk about in this format. You actually need to sort of see a live demo of that to make that go.
That's exactly right.
You can't just sort of sit there and say, you do here. No.
But on the other hand, if you already have a virtual machine up and running,
Yes.
and someone is starting to spoof that, it does look like a legitimate vMotion event, in which case you would move over to the other side.
So if it's vCenter, and we know that vCenter knows about it, that's a case at which we say, because the first thing that comes out of the virtual machine isn't application traffic. The first thing that always comes out is a few ARP requests and those sorts of things. And so at that point, we can identify it, and that's when we go back to vCenter and say, hey, we just saw this over here. Is that cool? And they can translate into technical stuff. Is that okay? Is that cool? And it'll say, yeah, it's okay. You can do that. And then we know it. Otherwise, we're going to shut one of them down. So there is enforcement of that policy that says one virtual machine, one MAC.
But that would require vCenter integration.
So why wouldn't, if you have SRIOV and you effectively you have network functionality in the server on your NIC with the switch A6 on there?
Yes, sir.
Why wouldn't you move the forwarding plane into that NIC and then have 802.1x running over SRIOV into was effectively you push your whole Brocade network all the way into the NIC of the server.
Well, my understanding of SRIOV is not that it moves the forwarding plane. I could be wrong, but
they could. I mean, I know it may not be doing that now, but the
no,
NIC itself
it just presents the hypervisor, the operating system, with multiple NICs, even though there's only one NIC.
Yes, but what he was saying is that he has a switch on a NIC.
Mm-hmm.
Okay.
Yes.
So the answer to that is we're ready for that. The very thing that you described, we can support, but it doesn't come without some implementation of that from the hypervisor vendors. Because they're going to be intercepting all of that traffic automatically, but the hypervisor vendors have to agree to do is we're going to step out of the way and allow you to have that direct SRIOV communication.
I know that's the bane of my existence.
Sorry, man.
So your switch on a NIC, is that a full-on, you have a forwarding table sitting on the NIC, or a hairpin all the traffic up to a northbound switch?
So the nice thing about it is because, and this is going into our fabric adapters now, so it's a little bit different than what we were going to talk about, but the point is that because of the nature of the traffic and the number of virtual machines that live on that host, it's easy to say, is it here? Nope, then it must be out there. So that means the sizing that I have to do is a lot easier than the size for the generic networking case. So that means you can think of it as being a sort of a smaller instance of a switch that's in there, but because I know that I don't have to deal with networking traffic in general, it's only for this specific subset, I can take some shortcuts, which allows me to put it in a very small form factor.
Okay.
Very efficient form factor.
Okay.
And get enough like CAM memory and things like that so that I can look up things quickly and still have strong switch behavior.
So some of the vendors have, they do sort of the same thing, but it's not really a switch locally. They just throw all the frames up to the northbound switch, and then the forwarding decision is made on the northbound switch, which is what UCS does, and I think some other vendors do too.
We can do that too.
Okay.
And the reason we have to be able to do that is because we can't depend on someone having one of our adapters sitting up in the server. Or somebody may have their own embedded blade service that's sitting up there. So once again, we had to cover both bases, so we have both products.
But yeah, the fact that you can do the switch even on the NIC is pretty cool.
Yeah, it's pretty neat. It's fun to watch, to see all these virtual machines communicating, no hypervisor involvement and no network traffic.
I think that's the long-term future. I think the architecture of the hypervisor providing switching features is going to fade out. And they're either going to have software switches which are externally configured and controlled, right, such as the Nicira type things, or, and the hypervisor vendors are going to say, don't use our. They'll provide some very simplified functionality, such as the vSwitch, which is fairly dumb, and then use advanced switching, or it's either going to be a NIC, which has either local switching capabilities or some fancy silicon that actually handles the networking going forward.
Or they'll just put switching ASIC, right on the motherboard, PCI channel directed to the CPU, and it'll be either. I mean, the long-term thing is there's actually two things happening. Either the network is going to extend into the server, or the server components are going to be broken apart and attached to the network. For instance, storage, and we're still right now kind of stuck with, which is why you integrate with VM Center, this sort of barrier to moving forward between what is your special sauce, right? The Brocade network. That's right. And the actual servers.
That's right. And by the way, with as far as that separation goes, it's the big piece there is that we don't want to introduce another point of management, right? That if we do put that switching ASIC on the motherboard, or we do put it inside of a NIC, we don't want to create yet another thing that needs to be managed, because then we're right back to the solution that one of my competitors had, which said, let's just add a whole bunch of logical switches in addition to what we already have. The secret there is going to be the manageability of it and the ability to enforce policy, so that says that with one global set, or in a sense, the fabric reaching into the server, so that now if I have a policy that says these two virtual machines can talk to each other, that policy has uniform enforcement if they're on the same server, or if they happen to be across two separate servers.
Yeah. We don't want separation. The last 20 years in data networking has been separation of the server from the network.
That's right.
What we want is integration. We want the networking to be bound into the server and the server to be bound into the network. And that's the fundamental attitude shift that we have to change, is say that, and that's what's not happening today. So the hypervisor vendors, which is what your point is, they're not integrating with the network.
That's right.
The network is starting to provide APIs to integrate with the servers, but we're not seeing the response back.
Yeah, I mean, we used to be, we had the servers and we had the networks, and never the twain shall meet. And now some idiot want to put a switch instead of a server. I don't mean they're an idiot, but it's really screwed up the way we deal with it right now is very unideal.
That's right.
It sounds to me, honestly, that this NIC that you produce is a ripe case for SDN, because rather than move a full-on Brocade OS to manage that switching hardware, that NIC could register to the switches attached to, and then that switch could program the forwarding tables inside that NIC.
Well, that's how a fabric works, though. I mean, that's what you have just described is precisely the propagation that takes place inside of a regular fabric. So whether it's one that's embedded in the switch or whether it's two standalone fabric switches, the behavior is the same. It's just where does that switching element...
Where's the forwarding table come from?
The fabric channel could be the ultimate hipster. I mean, they were doing it before it was cool.
That's right.
Excellent. Fiber channel as a hipster. I do actually think that might be a great place to wrap up, because that warms the cockles of my heart. Thank you everybody for participating in our hard cores versus soft edges discussion. I'd like to thank Ivan for talking about us, and I'd like to thank Chip for joining us, Derick Winkworth, Tom Hollingsworth and Tony Bourke. As always, remember that we provided an overview in session 1. In session 2, we talked about converged networking, and in session 3, we talked about multi-chassis versus multi-pathing. And this is our final, in the fourth session, on hard cores and soft edges. Of course, I'm Greg Ferro. You can catch me on Ethereal Minded on my blog at Packet Pushers, and you can find out more about Tech Field Day and the event of the virtual symposiums at techfieldday.com. Thanks very much for watching.